So, first question on this SAC is pretty straightforward. It's asking us for the average. Find the average, turn on voltage, and then calculate Planck's constant. So the first thing, 1.7 plus 1.32 plus 1.4 divided by 3, and that gives us 1.47. 1.47, and that's in volts. So 1 mark for that. Next part says determine Planck's constant. So Planck's constant is equal to H equals lambda V over C. So the wavelength up here tells us 650 nanometers, so 650 by 10 to the -9 times by the average voltage, which we have is 1.47, over speed of light, 3 by 10 to the 8. Working that out gives us 3.2 or 3.19 by 10 to the -15, and that's in, what are we using there, joule seconds. Done. For the above value of Planck's constant, determine the tolerance. Okay, so a couple of ways you could have gone about this one. You could have used, well, anything as long as you justify. Okay, so one of the options, the V average, if we used V average equals 1.47 plus or minus 0.05 of a volt, which means you've got a V max. This is 1.52 volts. V min equals 1.42 volts. And then working out the same, H equals lambda V over C using maximum and minimum. For a max, we end up with H max equals 650 by 10 to the -9 multiplied by 1.52 over 3 by 10 to the 8, and that gives us 3.29 by 10 to the -15. So that's for our max. For our minimum, is equal to 650 by 10 to the -9 by 1.42 over 3 by 10 to the 8. And that's going to give us 3.08 by 10 to the -15. So there's your range. And then from there, to write that appropriately, so H equals 3.19, because that's the midpoint between the two, plus or minus 0.1, which can become 3.2 plus or minus 0.1. Once again, you can word your justification about, well, if we've rounded that up from 3.19 to 3.2, we can make that larger. Other things that you can look at could have been, when you look at these values, you can look at the range. So the range there is 0.38. So therefore, if that's the range, then you might say, okay, then could be plus or minus 0.19, which is 0.2. Anything along those lines, so long as you're justified and you work out your maximums and your minimum values, and then you state it for your Planck's constant in the form of plus or minus. Okay, that's that one.